In the last video, we left off showing that the way we're going to calculate the accumulated value of an annuity is to calculate the future value on $1 per term and then multiply that result by the actual payment you make every term. So in this case, the annuity was for $300 per year, and so we calculated the accumulated value on $1, which was $3.21, and then we simply multiply that by 300. So that is going to be the strategy moving forward. As if you look back, this is how we calculated the future value on that $1 annuity. Now, suppose this problem involved doing this for 25 terms or 25 periods or 50 periods, then this would be very, very tedious. Fortunately for us, there is a formula, and we looked at this earlier. So here is the formula. This portion here gives us the accumulated value on $1 per period. And so let's use this formula to do that problem we just did. So this is a general formula. Notice we're making payments R for a certain number of periods, and then we simply use this formula to calculate the accumulated value on that $1 per period. Here we have the same problem, and let's first write down the little formula. The future value, let's just use S right now. S is going to be equal to R times 1 plus the interest per period raised to the number of periods minus 1 divided by the interest rate per period. And so for this problem, R is 300. So notice that's like this 300 here, and then this expression here will give us the accumulated value on 1 year. I'm sorry, on $1 per year. And so this becomes 1 plus 0.07. It's compounded annually. That's why this stays. We don't divide this by anything. Well, we divide by 1. And then it's raised to the third power, because it's 3 periods, and then minus 1. And then divide all of that by 0.07. And lo and behold, what do we get? 3.2149, and then when we multiply this out, we get 964.47. So obviously this is an easier way. You need to understand what this expression is doing. It's calculating the future value on an annuity of $1 per period. In this question, we're asked to find the accumulated value of an ordinary simple annuity of $2,000 per year for 5 years, and the rate of interest is 11% compounded annually. So each payment will be a payment of $2,000. How many periods? It's going to be 5 periods. And what's going to be the interest rate per period? Well, 11%. In other words, this is J1 equal 11%. Always draw your timeline. So here we have our timeline, and every time we make a payment, we'll be paying $2,000. So the calculation of this becomes really easy. So I have it set up over here. We just need to find the values of I and N. So I is 0.11, and N is 5 terms, 5. Remember, you need to understand what this number means. 6.2278 means that if we were to invest $1 every year for 5 years, then at the end of those 5 years, we would have $6.22. Of course, since we're investing $2,000, we need to multiply that value by 2,000, which gives us then $12,455. So I think that was easy. Don't you agree? Per her agreement with the bank, Sue is paying $580 a month. Unfortunately, she misses payments for March, April, May, and June. So she misses 4 payments. What single payment must she make in July to get back on track? So you have our timeline. Always draw your timeline. So she's making all her payments. Then she misses March. Then she misses April. Then she misses May. And then she misses June. And of course then she wants to pay in July. And then of course she continued making payments after that. So what we need to do then is simply find out what the future value of these payments is. What will be our focal date? Our focal date will be right here. All we need to know then is, well, the accumulated value of these payments. Now remember, she didn't make these payments, but the bank needs to know what those payments are worth. Now you can't simply add up these values of 580 that she missed, because remember, time means money. So we need to find out, this 580, what is its value here? This 580, what would be its value here if she had paid it? So we know that R is 580. We know that it's 5 payments, 1, 2, 3, 4, 5. And so what is the accumulated value of all these 5 payments? And so now here we have to be careful with I, because she has to pay interest at J12. That means it's compounded 12 times a year. So to get the interest for one period, you have to take 0.16 and divide it by 12, which gives us 0.0133. All we need to know is the value of the payment, the number of periods, and the interest rate per period. And we simply plug it in here. At $1 per period, she would have to pay here $5.14 approximately. But it's 580 per period, so we simply multiply 580 by this. So what she has to pay is $2,978.35. So I hope this is becoming easy for you. This is not hard at all, and I hope you see it that way. Okay, so that's it for this video.